Okay, today we're going to look at solving equations using logarithms, also known as logs. Okay, so here's our first equation. The log of x plus the log of 3 is equal to the log of 12. Before we can do anything with this equation, we have to condense the logs down so that we have one log on each side of the equal sign. So the first thing we're going to do is we're going to condense the one on the left. Remember, since it's a plus sign, we're going to be multiplying those values, so 3 times x, and that's going to equal the log of 12. Then, in order to get rid of the log, we're going to raise each equation to a base of 10. That turns this into an exponent now. So it's 10 to the log and then 10 to the. These values are going to then cancel out on both sides, and you're going to end up with 3x equals 12, and then divide by 3, and you get x is equal to 4. Here's another example. This time, the logs are only on one side of the equal sign. Again, we're going to condense our logs before we can do anything else with them. So we have a log base 3 system, and it's a subtraction, so we know we're going to be dividing. So we're going to be taking, okay, so as I said earlier, we're going to be dividing. So we're going to have log base 3, and we have x divided by 4 is equal to 5. We're going to raise each to a base of 3. That's going to cause the logs on the left to cancel, leaving as x divided by 4 is equal to 3 to the 5th, which is 243. We multiply both sides by 4, and we get x is equal to 972. Sometimes there's not a log on either side. For example, 5 to the x is equal to 35. In order to solve for x, which is an exponent, we need to bring it down, but the only way to bring it down is if we have a log on both sides of the equation. So we're going to take the log of 5 to the x is equal to the log of 35. That allows us to bring our x to the front, and so we have x log of 5 equals the log of 35. Finally, we divide both sides by the log of 5, giving us an answer, and the log of 5's cancel on the left, giving us an answer of x equals the log of 35 divided by the log of 5. In this x example, we're going to have to get the log by itself, so we're going to go ahead and subtract 2 from each side. This gives us the log base 3 of x is equal to 1. Once again, we raise it to a base of 3, which causes the left-hand log to cancel, giving us just an x on the left-hand side, and 3 to the 1 is 3. Finally, we'll look at an example with e. And you notice here it's 5e to the x plus 1, the exponent of x plus 1. That tells us we have to get that exponent down, which of course is going to involve using some type of log. Before we can do that, we have to get the exponent by itself. So we're going to divide both sides by 5. That leaves e to the x plus 1 is equal to 2. Now we're going to take the natural log of both sides. Sorry about that. Now we're going to have to take the natural log of both sides. Got my natural log. So that goes here. And then that allows us to bring the exponent down to the front. So we get x plus 1. Natural log of e is equal to the natural log of 2. Natural log of e is equal to 1, so it cancels out, leaving as x plus 1 is equal to the natural log of 2. We subtract 1 from each side. We get the natural log of 2 minus 1 as our solution. Okay, so that's a number of examples. If you have any other questions about this, how to solve equations using logs, let me know in class tomorrow. Don't forget, it's time to start your test review. See you tomorrow.